Approximately 13.75 billion years ago, our present-day universe was formed. Soon after, primordial light began to spread throughout the early universe and continued to do so across the cosmos. The universe itself also underwent expansion during this time, though its rate slowed down after the initial eruption. Since then, the rate of expansion has been steadily increasing, largely due to the influence of dark energy. In essence, the cosmos has been growing at an ever-increasing rate since its inception. For centuries, physicists and mathematicians have been studying the universe's nature, trying to unravel its mysteries. However, some scientists delve further into the unknown by pondering what lies beyond the boundaries of our universe. Is it possible that there are other universes, worlds whose existence we can only speculate about? This could very well be the case. Here are 5 theories about what this something beyond our universe could be, and what clues support these theories. The concept of a universe having an outside is a complex one because it requires a more precise definition of the universe itself. The term observable universe is a better formulation because it takes into account the speed of light, which plays a major role in what we can see. Since we can only observe objects when the light they emit or reflect reaches us, we can never see beyond the greatest distance that light can travel within the time the universe has existed. Cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light-years since the Big Bang, meaning the observable universe is about 93 billion light-years in size, give or take a few light-years. Everything we can observe, including quarks, quasars, stars, planets, nebulae, black holes, and more, is contained within this roughly 93 billion light-year radius. However, the observable universe only contains light that has had time to reach us, which means it is getting bigger as more light reaches us. The universe itself is finite, and the limit is known as the Hubble volume, named after the telescope that has given us the most distant views of the universe. We will never be able to see beyond this limit, so it's the only universe we can ever interact with. Astronomers believe that space beyond the Hubble volume could also be infinite, with matter, energy, and galaxies distributed much like in the observable universe. Beyond the Hubble volume, there may be more planets, including Earth-like ones. If we go far enough, we may find another solar system with an Earth that is identical in every respect, except for the choices we make in our lives. Cosmologists believe that if we go far enough beyond the boundaries of our universe, we will find another Hubble volume that is completely identical to ours, and in those other Hubble volumes, there is another version of us that reflects every possible action we might take. This seems unlikely, but the infinity of the universe is hard to comprehend because it is beyond human imagination. According to the theory of relativity, objects that are close together cannot move against each other faster than the speed of light. However, there is no such law for objects that are extremely far apart, as the space between them expands. This means that objects are not moving faster than the speed of light, but rather the space between them is expanding, causing them to fly away from each other at incredible speeds. Ultimately, this means that we could only reach the edge of the observable universe if we developed a method of transportation that would allow us to travel faster than the speed of light or transcend space-time through wormholes or warp propulsion, which most physicists believe to be impossible. In 2008, astronomers made a surprising discovery: galactic clusters were moving in the same direction at incredible speeds, over 2 million miles per hour. This phenomenon, known as dark flow, was confirmed by new observations in 2010. Scientists discovered this phenomenon by studying some of the largest structures in the cosmos, giant galaxy clusters, which are collections of about 1,000 galaxies and very hot gas that emits X-rays. By observing the interaction of X-rays with cosmic microwave radiation, CMB, left over from the Big Bang, scientists can study the motion of clusters of galaxies. The X-rays scatter photons into the CMB and shift the temperature in an effect known as the Sunyaev-Zeldovich kinetic effect. This effect had not been previously observed as a consequence of clusters of galaxies, but was first noticed by a research team led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center. They examined about 700 clusters that were up to 6 billion light-years away, halfway across the universe, and compared them with the map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe, WMAP, satellite. The motion of the clusters defies all predictions about the distribution of mass in the universe after the Big Bang. One possible cause of this is massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of the suction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our point of view. As for the structures themselves, they could be anything from accumulations of matter and energy on almost unimaginable scales to bizarre fault lines that conduct gravitational forces from other universes. There is another version of the story that suggests the expansion of the universe after the Big Bang created bubbles in the structure of space. Each bubble stopped expanding with the rest of space and formed its own universe with its own laws and physical constants. In this scenario, space is infinite and each bubble is also infinite. This is because a single infinity can contain an infinite number of infinities. Even if you could somehow break through the boundary of one bubble, the space between the bubbles would still expand, so you would never reach the next bubble no matter how fast you move. Physicist Lee Smolin proposed a theory called the theory of fertile universes, which suggests that every black hole in our universe could cause the creation of a new universe, and each of these new universes may have slightly different physical laws than the previous one. According to this theory, laws and physical conditions that lead to the frequent formation of black holes could also be the reason for the formation of other universes. Thus, this theory suggests a kind of natural selection for universes, where universes that form black holes have a greater chance of survival compared to those that do not. However, Smolin himself and others have since disproved this theory. There are countless theories about parallel universes, but the most accepted one today is an extension of the string theory. It involves oscillating membranes in other dimensions, which create new universes when they collide. These universes have different physical laws and are completely distinct from our own. The collision of these membranes also helps explain the observed distribution of matter in our universe. One of the strangest aspects of the theory is that all the gravity we experience in our universe enters from another universe in another dimension, which accounts for why gravity is weaker compared to other fundamental forces. This begs the question of whether other unknown worlds exist beyond our universe and the extent of infinity. The theory of parallel universes, the warping of matter, string theory, membranes, and black holes are all fascinating topics that raise questions about the nature of the universe. Do you think these ideas are nonsense, or is there merit to them? Leave your opinions in the comments below, and thanks for watching.